Square roots and surface area. So, what's a square root of a perfect square? We first need to know what a perfect square is. A perfect square is when a number is square rooted, but the answer is a whole number. Let's take 4 as an example. If you square root 4, the answer is 2. But if you square root 14, it's 3.7. And 3.7 isn't a whole number. So, is each fraction a perfect square? Pause the video to do it on your own. Now, we can just split this fraction into 2 different numbers. 8 and 18. Now, the square root of 8 is not a whole number. So, the fraction isn't a perfect square. 16 and over 9, you can just split into 16 and 9. Well, 16, its square root is 4, so it is a perfect square. What about 9? 9, if you square root it, it's going to be 3. So, yes, this is a perfect square. What about 2 over 9? I split 2 and 9. As we know last time, 9 is a perfect square because its answer is 3. But what about 2? It's not. So, unfortunately, this is not a perfect square. Now, 25 and 36. The square root of 25 is 5. Surprisingly. And 36's square root is 6. So yes, this is a perfect square. So now we know about perfect squares. What's a non-perfect square? Many fractions of decimals aren't actually perfect squares. And as we know for the title, they're non-perfect squares. They have a decimal number when you square root it. Remember in the last slide, root 14 was around 3.7? You can call 14 a non-perfect square. So, we can actually approximate the value of each square root by rounding the number to the closest square. Let's just take 8 over 5 for an example. 8 is close to 9, and we know that 9 is a perfect square. And 5 is close to 4, which is another perfect square. So the approximate value of each square root for this one would be 9 square root, which is 3, and 4 square root, which is 2. We can continue doing that for the others. Pause and try to do it on your own. Okay, let's do it together. For 3 over 10, 3 is close to 4, and 10 is close to 9. 4 square root is 2, and 9 square root is 3. What about 3 over 7? We know that 3 is close to 4 because we did it last time. And 7 is more closer to 9 than it is to 4. So the square root of 4 is 2, and the square root of 9 is 3. But what about 19 over 6? 19 is closer to 16 than 25. And 6 is closer to 4 than it is to 9. The square root of 16 is 4. And the square root of 4 is around 2. Now let's stop talking about square roots. Let's talk about surface area. So what is surface area? Surface area is the area of a 3D object with only its face is being shown. The surface area of a 2 by 2 by 2 cube would be a square which has the dimensions of 2 by 2. And there's 6 different faces. So you would do 2 by 2 times 6, which is equal to our surface area. 2 times 2 is 4, and when you times that by 6, that's 24 units squared. That's our surface area. But what about composite objects? So let's talk about the surface area of composite objects. what is a composite object? A shape which is actually more looking like it's to more than one shape combined. That's a composite object. So how would you solve the surface area of this object, which looks like 3 cubes stacked above each other? Now we know the measurements of this wonderful cube. It's 10 on one side, 10 on the other, 5, 5, 5, 5, 5. There's so many numbers. So let's just split into front, back, top, bottom, right, left, like that. So in the front we can see there's 3 squares, as we can see by the lines. It looks like 3 cubes have been attached. So the dimension is 5 by 5 here. And 5, because this is here, 5 by 5, and 5 by 5. That's the same at the back. 3 5 by 5s. The top, there's 2 5 by 5s. One is here, and the other is right over here. Now, in the bottom, there's actually a rectangle, which is 10 by 5. On the right side, it's the same thing. A rectangle, 10 by 5. But on the left side, there's 2 squares again, like the top. 5 by 5 and 5 by 5. Instead of writing it like this, let's just write in a formula. Our formula is a square has base times height, and a rectangle is also base times height. So we can use these as 3 squares. So these are our front, these are our back, these are our top, these are our left squares, this is our bottom, and this is our right. And when we multiply all of these together, it's going to give us 350 units squared. Remember, do not multiply this part. You have to add each and every side. Now, how do we solve overlapping objects? First, you need to find the surface area of the objects as they work together. A cube, which is 4 by 4 on 6 sides, is 4 times 4 times 6. 16 times 6 is equal to 96 units squared. While a cylinder, we know that to find this circle part, it's pi r squared. But because we have 2, we're going to also times that by 2. Now our radius was 1, and our diameter is 2. So we're going to do pi times 1 squared. 3.14 is our answer. But there's also the bottom side, so we're going to times it by 2. 3.14 times 2 is equal to 6.28. But what about that straight side? The one which rolls properly. That's actually pi d. We need to find the circumference first to find the length, then the width. We know our width is 4, but what's our length? Pi 2 is our width. As we multiplied pi with 2 already, 6.28 is our answer. And we times that by 4, which gives us 25.12. Now we add both of these, and 31.4 units squared is our cylinder's area. But which part overlaps? The bottom of the cylinder. And the area of that is 3.14. And it overlaps with the same exact area on the cube. So it overlaps twice. So we're going to multiply 3.14 by 2, which gives us 6.28. Now, here's the tricky part. We first need to add 96 and 31.4, but we also have to minus 6.28. And when we do that, we get 121.12 units squared. Thank you. Please like, share, and share this video with others. Please subscribe to our channel as well. We hope you enjoyed watching this video. This is Infinite Information signing out.